Artificial intelligence is absolutely brilliant at knowing individual facts. But its biggest challenge? It's understanding the hidden connections between those facts. So today, we're diving into the tech that gives AI a true relationship superpower, graph databases. So let's start there. What exactly is this core problem? I mean, with all the incredible power AI has, where is it still falling short? It really all comes down to one simple question. With everything AI can do, from writing code to creating art, what's its biggest blind spot? And the answer is context. You see, AI systems, especially the ones built on vector databases, are fantastic at finding things that are similar. That's why your product recommendations and document searches work so well. But what they often miss is the story, that whole web of relationships that explains how or why things are connected. They see all the individual puzzle pieces, but they have no idea how they fit together. And this leads us to a really crucial distinction, one that represents a pretty fundamental shift in how we build intelligent systems. It's this idea of finding simple similarities versus truly understanding deep connections. Okay, let's use an analogy to make this super clear. A vector database looks at a forest, and it's great at pointing out all the pine trees. Why? Because they're all similar. A graph database, on the other hand, sees the entire ecosystem. It understands how that tree provides shade for a certain plant, how its roots hold the soil together, and how it connects to the animals and the water sources nearby. It doesn't just see the what, it truly sees the how. So, how do graphs actually pull this off? Well, it really just comes down to two basic building blocks. The first one is called a node. The easiest way to think about a node is like it's a noun. It's an entity, a person, a company, a movie. It's the thing in your data. And the second, and you could argue this is the more important piece, is the relationship. Sometimes people call it an edge. Now, if the node is the noun, the relationship is the verb that connects our nouns. It's not just telling us that two nodes are linked, it tells us how they're linked. A person works for a company. A movie was directed by a specific director. This right here is where the story and all that rich context comes from. So, now that we have our two key ingredients, nodes and relationships, let's see how they come together to build a much more intelligent system in the real world. We all get recommendations from streaming services, right? So let's use that. How can a graph make a movie suggestion so much smarter and more personal than just finding, say, similar action films? Okay, so here's how it would work. Step 1, a standard vector search kicks things off and finds movies that are similar to ones you already like. Pretty standard stuff. But then the graph kicks in. Instead of stopping there, it asks a much more interesting question. Who among your friends also liked those movies? Then it takes another leap, asking, okay, what other movies did those specific friends enjoy? All of a sudden, your recommendation isn't just based on genre, it's based on the shared tastes of people you actually know and trust. See the difference? And that's the crucial point. The intelligence here isn't coming from just matching keywords or features like sci-fi or action. It's coming from traversing the connections, from you to your friend to another movie they liked. The path itself is the insight. And this amazing ability to follow connections, well, it's not just for figuring out what to watch on a Friday night. It has massive implications for pretty much any industry where the relationships between the data points are the real story. And you really do see this popping up everywhere. Big companies are building these huge internal knowledge graphs to map out how all their data, people, and projects connect. Banks are using graphs for fraud detection to spot those subtle, unusual links between different accounts that might signal a problem. It's even powering this incredible new tech called GraphRAG, which lets large language models reason over connected data, giving them a much, much deeper understanding before they generate an answer. So the big question is, when do you actually use this? Well, the choice is pretty clear. If the connections and the relationships in your data are the main event, if that's where the value is, then graphs are almost certainly the answer. But look, if a simple find me things like this similarity search is all you need, then a standard vector database is probably going to do the job just fine. And that really brings us to the future, doesn't it? It's becoming crystal clear that the next generation of AI isn't just going to be about processing more and more data, but about understanding it on a much deeper level. All right, so if you take away just 3 things from all this, let it be these. First, graphs give AI the one thing it's been missing, a real, genuine understanding of relationships.
Second, the most powerful AI systems actually combine both. They use vector search for that initial similarity match, and then they use graphs to explore the connections. And finally, the golden rule. If the story connecting your data is just as important as the data itself, you need a graph. Because as we move forward, the true measure of artificial intelligence isn't going to be the sheer size of its memory, but the depth of its understanding. It's really about seeing the forest and the trees, and finally, understanding how they all connect. Thanks for tuning in.